What is a function, and why was there milk in the thumbnail?
Here's a gallon of milk. In the US, dairy cows produce an average of 8 of these things per day. That means a farmer with 1 cow gets 8 gallons of milk per day, a farmer with 2 cows gets 16, and so on. If I asked you how many gallons of milk would 32 cows produce in a day, you would be able to tell me, because it's a pretty predictable pattern.
And that's the point of a function. It's an equation that takes an input and gives an output. For cows, that looks like f of x equals 8x, with the input being the number of cows and the output being the gallons of milk. You can substitute in any number of cows for x, and the function will tell you how many gallons of milk they can produce in a day. Let's look at another example. I can represent a function using a blender. Now, imagine this blender is a function. We can put our inputs in like fruits, berries, and the function will output things like smoothies. So, if I put this banana into the blender, it will output a banana smoothie. This is how all functions work, and we can represent this by saying something like f of banana equals banana smoothie. The f with the parentheses is what we call function notation. This just means that a function we call f has an input variable. Usually it's x. When we write f of banana, this means that we input a banana into our function, in this case the blender. The whole combination, f of banana, represents the output. In this case, that would be a banana smoothie. Let's go back to our dairy farm example. Our function for the dairy farm example is f of x equals 8x. Our input variable x represents the number of cows, and our output f of x represents the amount of milk that they can produce in a day. Earlier, I wanted to know how much milk would be produced in a day by 32 cows. We can substitute the number 32 for the x in our function and get f of 32 equals 8 times 32. And after doing the multiplication, it turns out that 32 cows produce 256 gallons of milk in one day. Another really useful thing that we can do with functions is graph them. We do this by putting our input variable on the x-axis and our output variable on the y-axis. We can use the graph to do many things with the function, but one really important thing we can do is evaluate the function using the graph. To find out how much milk 2 cows produce in a day, I can find 2 on the x-axis and see how high that point is on the y-axis. The y value of the graph when x equals 2 is 16, so that's how many gallons of milk 2 cows produce in a day. The last thing to know about functions is that every input can only have one output. If we go back to the blender, when we put in bananas, we get banana smoothies. But let's say hypothetically for a second that you could put a banana into the blender and get a blueberry smoothie out. Since every function needs to have only one output for every input, the blender would no longer be a function, since the input of a banana would have 2 outputs. When we graph an equation, there's a very simple way to tell if it's a function or not. We use the vertical line test. The idea is that if you run a vertical line over every input, the line should only touch the graph in one spot. If the line touches the graph in more than one spot, then it's not a function. In our dairy farmer example, a vertical line traveling across the graph only touches in one spot at a time. If we change our function, however, to something that looks like this, now when we do this vertical line test, there are places where the line touches the graph in more than one spot. This means that the equation is giving out more than one output for some inputs, and because of that, it's not considered a function.